Hi, I'm Jeff Crawford from Crawford's Auto Repair in Mesa, Arizona. Welcome to my free classes on automotive maintenance and repair. This lesson is one of 12. It's going to be on the drivetrain. We started out in an earlier lesson describing how an internal combustion engine works and how the engine converts reciprocating energy of the pistons into a rotary energy in the crankshaft. The crankshaft is then connected to a transmission, whether it be a front-wheel drive, rear-wheel drive, or four-wheel drive vehicle. They all have a transmission. The purpose in the transmission is to gain mechanical advantage so you can accelerate and drive your vehicle at lower speeds as well as higher speeds, because the engine is only capable of operating between set parameters within its RPM range. We'll start off by just demonstrating different types of vehicle. Over here we have a picture demonstrating a four-wheel drive vehicle with a transversely mounted engine, meaning the engine is in there sideways basically, and a front transaxle, and then a drive line going to a rear axle, so it's four-wheel drive. Next we have a conventional four-wheel drive vehicle which is going to have an engine mounted from crankshaft going from front to rear, then a transmission, a transfer case, and then you're going to have a front drive shaft from the transfer case going to a front differential, and a rear drive shaft from the transfer case going to a rear differential. Next we have a front-mounted engine and transaxle. This would be a front-wheel drive vehicle. What most vehicles on the road today are. We have an engine mounted sideways with a transaxle connected to axle shafts. A transaxle is called that because it's a transmission and an axle or differential combined into one, whereas a conventional drivetrain has the transmission and axle separate. Now we'll go to a conventional drivetrain. This picture demonstrates that. We have the engine mounted with the crankshaft from front to rear, then a transmission behind that, then a drive shaft connecting the transmission to the rear differential, and a rear differential connected to the wheels to drive your vehicle. We have all of these types of vehicles except the transversely mounted four-wheel drive. We don't have that as an example, but we do have a front-wheel drive vehicle for an example. We have a rear-wheel drive vehicle, and we have a conventional four-wheel drive truck. Now this is going to be a differential. This is what allows these spider gears inside, allow the left and right tires to go different distances so you can corner easily without dragging a tire. When you go around a corner, the inside tire always travels less distance than the outside tire. This set of gears right here allows that. Now this other set of gears, it's called a ring gear and a pinion gear. This is going to convert the rotating energy of the drive shaft input here. It turns it 90 degrees so that we have rotating energy that's going to come out here and go to the tires and transmit that energy to the ground. This is how a differential works in a transaxle. This part of the differential is built into the transmission. On a conventional drivetrain, the differential is separate and it's in the rear of the vehicle. Now here, this is a basic picture that shows how a manual transmission works. remove your gear selector, all of these gears are constantly in contact with each other. And all you're doing when you select the gear is you're connecting that gear to the output shaft. So all these gears are free spinning. They're not connected to this shaft until you select it. So you select this gear to be connected to the shaft, and then it uses this gear ratio right here to complete the output gear ratio of the transmission. A typical transmission, the gear ratios all vary, but in most manual transmissions and in automatics, in first gear you're going to be around a 4-to-1 reduction, which means the input shaft is going to go around 4 times, the output shaft is going to go around 1 time. That gives you a mechanical advantage so that you can drive at lower speeds, and it allows you to accelerate. As you accelerate up to the top of the engine's RPM, you're going to now select the second gear. Second gear ratio would typically be around a 3-to-1 gear ratio, meaning the input of the transmission is going to rotate 3 times and the output is going to rotate 1 time. Third gear is typically a 2-to-1 ratio. Again, that means the input shaft is going to go around 2 times, output shaft 1 time. In fourth gear, on most vehicles, the ratio would be 1-to-1. The input speed and output speed are going to be the same speed. At that time, you're going to be traveling at 45 miles per hour or above. You'll be in high gear or fourth gear. A lot of vehicles now have overdrive. Overdrive ratio would typically be somewhere around 0.75-to-1. So now the output speed is going to be faster than the input speed. So the input's going to go around 3/4 of a turn, or 0.75 rotations. The output's going to go around 1 full rotation. Next, we're going to move into the automatic transmission. Automatic transmissions are very complicated, and it's almost like magic the way they work. They have a series of gears. Now this is a picture of a sun and planet gear. The sun being the center here, this gear would be the sun gear. These would be planetary gears, and this would be the ring gear. You can hold this part of the gear and turn this part of the gear, and you get a gear reduction on this gear. You can also hold this gear, turn this gear, and get a different gear reduction at this gear, or you can hold this gear, turn this gear, and get another gear reduction out of this. So each one of these gear sets is capable of 3 different gear reduction ratios, as well as changing the direction of the output, being from forward to reverse. Now every time, I didn't go through that in a manual transmission, but every time you add a gear, the rotation of the next gear is going to be reversed. So to achieve the same direction of rotation input to output, it requires the gear to come in here, down here, over here, up here, and then out. That's how the transmission works. These bottom gears are mounted rigidly to a shaft. These gears are not mounted to a shaft. You select which gear attaches to the shaft, which gives you your gear ratio and allows the vehicle to go. When you shift a manual transmission into reverse, you have a separate reverse idler gear that is this one. This gear right here is the reverse idler gear. That gear is put in there for that. As I said, every time you add a gear, you reverse the direction. So you're now using 3 gears instead of just 2. That gives you a reverse rotation of the output shaft on the transmission. Now, this is an actual planetary gear set. We don't have the sun gear, which would be the gear inside of here that turns all of these. So as these turn, then they would turn the planetary gear, so you get a gear reduction. But you, as I said, you can hold this part of the transmission, you can hold the sun gear, the planet gears, or the ring gear independently, all which will give you different rotations and different gear ratios. An automatic transmission can have 2 to 4 of these inside of it, depending on the number of gears it has. And then it has bands which can apply and hold the outer sections, or the sun, or the ring gear, as well as clutch packs, which would be attached through a drum to hold the planetary gears. So again, it's all activated hydraulically, and they're very complicated. It would be difficult to explain that to those people on a video, so we're going to keep it simple in here. Now we're going to go and we'll walk over. I guess we'll start out with this truck we have up in the air. It's 96 Dodge 3/4 ton 4-wheel drive with a Cummins diesel engine. We're not really going to go into the engine today, but I will show you that the whole drivetrain has been removed. We're actually modifying this transmission to withstand up to 1,000 horsepower. We're putting a lot of special high-performance parts into it. Customer wants to tow a heavy trailer, and they're modifying the engine up to 500 horsepower from 250. So we're going to modify the transmission as well as the engine so that the vehicle could be reliable and tow an extremely heavy load at a comfortable pace. We'll start out with the transmission. Transmission is this portion right here. It has a series, that set of gears over there are going in this transmission. So it has a large torque converter, which is a device that uses fluid to compress the fluid, and it drives the input shaft of the transmission. Then it goes through the transmission through a series of sun and planet gears, again selecting which gear ratio you're in. When you take off, it's going to be in first. As you accelerate, if this is an automatic, it's going to automatically shift to second, then third and fourth. Beyond that, we're going to move to a transfer case. A transfer case is a separate gearbox. When you're in 2-wheel drive, it's basically a solid shaft through here, and none of these other components are turning. So all this is just sitting here really doing nothing. It just is a solid shaft from the input to the output, which connects to the drive shaft. Now when you select 4-wheel drive through a separate shifter, it's going to move this lever. It's kind of hard to move, which is going to engage this drive shaft. It's actually engaged right now, which would then connect to this drive shaft here, which is connected to a front differential, and it allows the vehicle to turn all 4 wheels. In this application, you can only engage 4-wheel drive when you're on slippery conditions or in the dirt. If you were to engage the 4-wheel drive on this vehicle on the pavement, it wouldn't want to turn or go around corners. So now we'll move on to the driveline. We have a 2-piece conventional driveline here. It has a universal joint in the front, which allows the driveline angle to change. Now we have a carrier bearing, or a center support bearing, in the middle. This bearing is because the drive shaft is so long, we want to split the angles so we don't have too steep of an angle on the pinion angle on the driveline or on the rear end. Then we have a slip yoke. A slip yoke on a driveline is this part right here. It allows the drive shaft to change lengths as you're going down the road, because when you go over a bump and the suspension goes down or up, the length of that drive shaft needs to change. And in the back we have another universal joint. Again, the universal joint, it allows the angle of the driveline compared to the rear end to change. As the vehicle's driving down the road, the rear end is moving up and down. The transmission and engine are mounted in rubber. Next we'll go to a differential. This is the rear differential. If you notice, it's a solid piece of steel across here. It has ring and pinion gears inside, as well as spider gears and side gears. Those would be called the differential. This transmits the power, and it converts the power from rotating in this direction to rotating in this direction through the series of a ring and pinion gears and spider gears. Now we'll move to the front axle. The front axle is more complex because the front tires need to turn. So the front axle, again, it looks the same right here. All the way out to here, we have a differential and a ring and pinion gear inside of here. Drive shaft connects here. We're going to come out, this is where it changes. Here we have a steering knuckle. So in order to be able to steer the front tires, we have to have a U-joint here. So we have another U-joint that allows the front tires to turn, as well as to produce power to the ground. Then we have tie rod ends, which are part of the steering system, that allow the steering wheel to turn the wheels left and right. On the other side, we have the same thing. We have a ball joint, upper and lower ball joint. They allow the steering knuckle being this part, to turn. It's connected to a tie rod end, which allows us connected to the steering box, allows the wheels to turn. Again, another U-joint on this side. That U-joint is to allow the power to flow to the wheels while you're turning still. That completes the basic components of the drivetrain on a 4-wheel drive vehicle. Now we're going to move over here to a 2006 Scion XB. This vehicle's lent to us by Myrex Marketing for purposes of making this video. If you're interested in any marketing needs, you can go to myrexmarketing.com. That's MIREX marketing.com. He can help you make a video or any of your advertising needs. Now we'll come underneath this vehicle. It's a little bit harder to see these components because they're installed in the vehicle. I'm going to try to use a light. Hopefully I don't make too much glare and make it hard to see. But this vehicle has a manual transaxle. Actually, we have a manual transaxle over here on the floor. It's out of a Volkswagen. I'm going to show you that. This is a used transmission we're going to install. Now, here we have a manual transaxle. So, this is going to be your input shaft. This is connected to a clutch disc. The clutch disc enables you to disengage the engine from the transmission so you can stop and hold the clutch in without moving while your vehicle is in gear, as well as being able to shift it when you depress the clutch. So right now the vehicle's in neutral. Over here we have the shift lever and mechanism. I'm going to engage it into a gear. You can see now that when I turn this, the output shaft is rotating. Now I'm going to select a different gear, and you'll see that it turns at a different rate. Now there, I must have been in reverse because now it's turning the same direction. Here it's going opposite direction, so that's reverse gear. That's a forward gear, different ratio. And this is going to be fifth gear. So we have 1, 2, 3, 4, and 5. So we have, this is a 5-speed manual transaxle. So you see that engine power is coming in here, and we're going to have an output on this side, and we're going to have an output on this side. Another axle bolts onto here. Now we'll go back under the vehicle, and you can see how it looks when it's installed. Okay, now we're going to go back to the 2006 Scion XB. This is going to be a picture underneath the vehicle of what a transaxle, and again, this is a manual transaxle, but the bottom of an automatic transaxle, it looks real similar. It may have a pan for changing the fluid. So we have the transaxle here, transversely mounted. In this section right here, we have a differential. The differential, again, is good to allow the vehicle to go around corners, because when you're cornering, the inside tire is going to cover a lot less distance than the outside tire. They need to go a different amounts of distance. Now we have an axle on this side, which is right here. It connects out to the wheel over here. You can see as I turn this, the wheel is turning and the axle is turning it into the transaxle. If you notice, one wheel is going one direction, the other is going opposite. That's because we have the differential. The differential does that. The vehicle's in gear, which means the crankshaft can't turn and the wheels will go the opposite direction. That's really all I can show you on the front wheel drive. Now we're going to move over here to a conventional front engine rear wheel drive with the transmission. We'll see how the lighting is if we need a drop light over here as well. So, just like what we have over there on the ground, we have a transmission, a bell housing. In the bell housing there's a torque converter, which is a fluid coupling between the engine and the transmission. The torque converter allows you to sit at idle with it in gear and not go. Once you depress the throttle, the torque converter engages more. Next we have the transmission pan. This is the transmission pan. In a previous video we demonstrated a proper servicing of an automatic transmission to remove the pan, replace the filter, top the transmission off with new fluid, and above that fluid level there's going to be a valve body. That valve body controls all the fancy hydraulics inside the transmission that allow it to shift automatically. Above that there's going to be input shafts, planetary gears, clutch packs, and bands. All those work together to give you all the different gear ratios, being 1, 2, 3, and 4 in forward and 1 in reverse, because this is a 3-speed with overdrive automatic transmission and 1 speed in reverse, obviously. That's pretty standard on most cars. A lot of modern transmissions are even 6-speed automatics now. Next we have a drive shaft. The drive shaft on this vehicle is one piece. It's not near as long as on the big truck, so we don't need to have a center carrier bearing. We do have a slip yoke in the front of the vehicle right here where it goes into the transmission. That allows the drive shaft to move in and out of the transmission to change lengths. Again, as the rear end moves up and down, the length of the drive shaft has to get longer or shorter. So we do have a slip yoke in the front. In the back we have another U-joint. The U-joint allows the angle of the drive line to change as the rear end is moving up and down when you drive down the road. As well as, now we're to a rear differential. Rear differential on a rear wheel drive vehicle is going to be the same as a pickup truck. We have a input pinion gear, a ring gear, differential gears connected to axles. Again, it turns the power from rotating this direction along the length of the vehicle out to the axles to the direction the tires turn. That's the purpose of the rear end. The differential allows the tires to go different speeds or different distances as you turn a corner. Well, thank you for watching this video. That concludes the explanation of drivetrains and rear end and all the options that are available. For more information, you can go to my website at www.crawfordsautoservice.com. Thank you and have a great day.